Okay, so I'll try to make this video short, but there's a lot to talk about, and it's all related to sine and cosine, and we're going to talk about some other trig functions. So, you want to know the unit circle, keep that handy. You also want to go back to geometry where we talked about this here. The sine of an angle is the opposite over a hypotenuse, and the cosine of an angle is the adjacent over the hypotenuse. And you may remember the third one, tangent. The tangent of an angle is the opposite over adjacent. So take a look at those three, keep those in your mind, and I'm going to show you another way to get at tangent, and the same way to get a tangent using sine and cosine. So let's take a look. If we take the sine of an angle and divide by the cosine of that angle is really what we're looking at. So if I take the sine of theta and I divide by the cosine of theta. If we go back to old school geometry, that would be the opposite leg over the hypotenuse divided by the adjacent leg over the hypotenuse. And fractions divided by fractions scare kids in high school, but if you know that dividing is really multiplying by the reciprocal, you can say that this times the reciprocal of that big denominator. The hypotenuses cancel and you get opposite over adjacent. And you get this really important idea that the tangent of an angle is the opposite leg over the adjacent leg. That is a perfectly wonderful way to think about it, but you can also think about it as the sine of theta over the cosine of theta. This will be a very important definition going forward, that we know that the tangent of theta is the same as the sine divided by the cosine. So what we'll do here in a second is we'll go around the unit circle. We'll talk about how you can find the tangent of all the special angles using this relationship. But we're also going to define another important relationship, new trig function. Maybe you've seen it before, maybe you haven't. There's actually 6. So we'll talk about a new one that's related to tangent. All right. So let's find some tangents here. Notice I'm only going to find them in the first quadrant, and then once I find them for the first quadrant, I can find them for any other quadrant by using symmetry. We just have to talk about the sign, positive, negative sign, SIGN sign. So let's take a look at all of these. Remember that the tangent is the sine over the cosine. So all I need to do is take the y-coordinate divided by the x-coordinate, and I get 0. Take the y-coordinate divided by the x-coordinate, so that's 1/2 times 2 over root 3, right? Because dividing is multiplying by the reciprocal. And we end up getting 1 over root 3, and we'll rationalize that to be root 3 over 3. Good. And then we sine over the cosine, that's an easy one, that's 1. And then here, sine over the cosine, that's root 3 over 2 times 2 over 1. Dividing is multiplying by the reciprocals, 2 cancel, and here you get root 3. And then the tricky one, 1 divided by 0. What is 1 divided by 0? What is 1 divided by 0? Hopefully you said undefined. There is no tangent of pi halves. You can't do it. It's undefined. So, just like with the sine and cosine only having a few values, these same 5 values, 0, root 3 over 3, 1, root 3, and undefined, happen all over the unit circle. So over here, you might think, oh, that's going to be root 3, but you would be wrong because it would be a positive over a negative. So here it's negative root 3. And over here it's negative 1. And over here it's negative root 3 over 3. And here it's negative 0, but that's just 0. And then down here, you get a negative over a negative. And that's where you're going to get a positive root 3 over 3. And here you'll get a positive 1. And here you'll get a positive root 3. And then down here, you're undefined again. Undefined. Down here, you get negative root 3. Negative 1. Negative root 3 over 3. And then we're back to 0. The tangent has some really interesting properties, though, that are worth looking at right here with the unit circle. Look at all of the angles across from one another. So let's take pi 6 and then across from one another that way. 7 pi 6. Do you see that they have the same value for the tangent? The same sign, S-I-G-N sign, positive, negative? Same thing happens right here. If you look at 3 pi fourths, and then on the other side, 7 pi fourths. Negative 1 and negative 1. If you look across here, undefined and undefined. If you look across here, 0 and 0. And this actually is a pretty slick way to memorize the tangent. Oh, let me clear those. A pretty slick way to memorize the tangent is to think about, back in geometry, what a tangent meant was a line that intersected the circle once. So imagine that that's the unit circle, and draw a tangent line right here. Good? Now, think about this value right here on the y-axis of being 1, and mirror that 1 over here on this tangent line, the same scale. That would be a 1. And right here is 0 on the y-axis, so this would be 0 on the tangent line. Call this axis the tangent of theta. And now you can actually visually see that if I do 30 degrees, I hit down here. If I do 45 degrees, I hit right there at 1. If I do 60 degrees, I hit up here. That value just happens to be root 3. And if I did 89 degrees, I would hit way up there, and the tangent of 89 would be a big number. But if I did the tangent of 90, I would never hit that axis. And that would help you remember undefined. If I did the tangent of 0, I would hit right there at 0. If I did the tangent of 2 pi thirds, I would hit way down there, because 2 pi thirds is here, and I can connect that through the center down to there. And so that's actually, I memorized those 5 values. 0, root 3 over 3, 1, root 3, and undefined. And I realized that this is the smallest, and that the values get bigger as I go this way. And then I just think about on the unit circle, am I hitting down here at 0? Am I hitting below 1? Am I hitting above or right at 1? Am I hitting above 1? Am I hitting undefined? And I can just chart the values this way. And if it's over in the second quadrant, they're negative. And if it's in the third quadrant, it's positive. Good? Okay. We'll do another trig function. This one is a new trig function, and it's actually called the secant. And again, just like the sine and cosine, they have abbreviations. The secant of an angle theta, and the secant, which we abbreviate with the first 3 letters, we write secant of theta. It's actually defined as the hypotenuse over the adjacent. And you might think, well, that sounds familiar. Hypotenuse over adjacent. That sounds a lot like cosine. So another definition for secant is the secant of theta is the reciprocal of the cosine, or 1 over the cosine of theta. So it is an important relationship. If the secant is the reciprocal of the cosine, then the cosine of theta is also the reciprocal of the secant. Those are important relationships, this and this. If I clear that and we go back to the unit circle, we could go through those values and we could look at the cosine and we could just take the reciprocal of all of these to get our new values for secant. So the secant of pi sixth would be the reciprocal of the cosine, so that would be 2 divided by root 3. Remember, we don't like that, so we multiply by root 3 over root 3. And I get that the secant of pi over 6 is 2 root 3 over 3. The secant of 0 radians or 0 degrees is 1 because the reciprocal of 1 is 1. This one here, the reciprocal of root 2 over 2 is 2 over root 2. But then you would rationalize that, multiply by root 2 over root 2, and you get 2 root 2 over 2, and those 2's cancel, and you get back to root 2. It's kind of nice. Here, the reciprocal of 1/2, there's an easy one for you, is 2. Similar to the tangent, though, you can't divide by 0, so the secant of pi halves is undefined. So the cosine of pi halves is 0. The secant of pi halves, that's the reciprocal of this, that does not exist, so we just say undefined. Right, if you want to write it out. But U and D, good enough. Undefined. Okay, the last little piece about secant and tangent is just this simple relationship I want you to see. We know that sine squared theta plus cosine squared theta equals 1. We talked about in class how that comes from the equation of the circle. If I divide this by cosine squared theta, and I divide this by cosine squared theta, and I divide this by cosine squared theta, the sine over the cosine, that's what we talked about at the beginning of the video, is tangent. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine is secant, so 1 over cosine squared is secant squared theta. This is another Pythagorean trig identity that's pretty important. So the one we talked about in class, sine squared theta plus cosine squared theta equals 1. That's a Pythagorean trig identity, and a related Pythagorean trig identity is this guy right here. Cool? All right, that should be it. Trying to keep it short. I try to talk a little bit about important math stuff in these videos, so hopefully you're watching and taking notes. We will have a quiz on Thursday, and if you write bubbles at the bottom of your quiz, you'll get a bonus point to prove to me that you're watching all of these videos and everything I say. All right, thanks, ladies. Remember, bonus is bubbles at the bottom of the quiz tomorrow. All right, peace.